Okay, let's start chapter 3, which is pretty much mostly going to be about lines and parallel lines to be exact. You're probably going to learn a whole lot of things about lines that you never wish and cared to know about, but yeah, that's part of geometry right here. So let's take a look. There are a lot of vocabulary terms um, you're going to need to make sure you know. Okay, once again, flashcards, Quizlet, whatever it takes for you guys to memorize these terms, know them by heart, so that especially uh, when it comes to taking your tests and working on proofs, you'll be able to successfully answer them. So let's start right here. I have highlighted in blue two lines that do not intersect are either parallel or skew lines. So whenever you think about, once again, lines that don't intersect, they're either parallel, and if they're parallel, they're on the same plane. Okay, they could be parallel. They could technically be on opposite planes, but we'll say that they're on the same plane. So they are parallel. Then, what we also said is this. If you think about it this way, lines that are skew. I have this line going like horizontally. This line is vertical. However, if you think about it like this, if I have it set up, you will see that they do not intersect. They may look like it from this perspective. However, this is exactly what is going on right here with the two lines. So they do not intersect. Two different scenarios right there. Two lines are parallel when they do not intersect and are coplanar. So actually, if we go back to our what I mentioned earlier, two lines that are parallel, they are on the same plane. So that's why they said right here, they are coplanar. Next up, in yellow, we talk about skew lines once again. Okay, so skew lines, uh, two lines are skew when they do not intersect and are not coplanar. Once again, so also two planes that do not intersect are parallel planes. So you can see that right here. It shows that planes T and U are parallel. We have lines M and N are parallel, and they are on the same line. And then right here, lines N and line Q happen to be uh, skew lines, or actually, sorry, line M and line K are skew because they do not intersect each other. Lines K and line N right here, they actually intersect. It also says right here in the fourth part, it says lines K and N are intersecting lines. Okay, and there is a plane not shown containing them. Okay, so let's go ahead and move on. Remember, 3 points make up a plane, so we could technically say, like right here, that line N or plane T, sorry, is not the plane that they are on. We can make a plane, take a piece of paper that like will intersect those two lines. That'll be flat right on it. Moving on, right here, if I take a look at lines M and N, we have these two arrows. So what this next part is telling us is that if you have these two types of arrows right here, then what that tells you is that those two lines, M and N, happen to be parallel. Okay, so that's how we know that lines are parallel in a drawing. You can see these two right here. Remember when we looked at chapters 1 and chapters 2, I knew that lines or like segments were congruent because they had the little hash mark, or I knew that angles were congruent because they had the little arc that goes through them. So I know that lines are parallel because of the marking right there in red. We also use, as you can see right here in blue, is that we have these two vertical lines, and that means that we have two lines that are parallel. Okay, so M is parallel to N, is what it shows right there. All right. Segments and rays are parallel when they lie in parallel lines. In yellow right here it says a line is parallel to a plane when the line is in a plane parallel to the given plane. So we could talk about a line, two lines being parallel, even though they're not on the plane, but they better be parallel. Their planes better be parallel. So that's why it says right here, line N is parallel, right here, is parallel to plane U. So we have several postulates. Take a look at postulate 3.1. It says if there is a line and a point not on the line, then there's exactly one line through the point parallel to the given line. So what they're saying is if I look at line L and I have a point right here, then there's only one line that's going to go through this point P that will be parallel to L, right? Because if I have a line going if it's crooked in any way, then what's going to happen is that they will eventually intersect. Therefore, they're saying that there's only one scenario right here where this line is exactly level to line L, or they have the same slope, is what we would say, and they would be parallel lines. Okay, because if you remember from algebra, we talked about lines that are parallel have the same slope. So that's what a few things that we have right here in our notes. Parallel lines have the same slope and different y-intercepts. Parallel lines, remember, never intersect, and parallel lines are coplanar. If two lines are parallel, or they appear to be parallel but they're not on the same plane, we can say that the line is parallel to a plane, but not parallel to the line that's on that plane. Postulate 3.2. If there is a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So what they're saying right here is this, that in line L, and there's line P, there is only one line that will go through point P and be perpendicular to line L. Only one line. Any other line that's not 90 degrees to each other, these two lines, they are not considered perpendicular. So remember, right here it shows perpendicular lines intersect and form 90-degree angles. Perpendicular lines have reciprocal slopes. Remember, if I have a slope right here where m is 1/2, the perpendicular slope will be the reciprocal of 1/2 is 2. And the negative reciprocal, it will be -2. So these would be perpendicular slopes of one another. I could start off with the slope being, let's say, -5. That will be perpendicular to the slope of negative or positive 1/5. If one is negative, the other one has to be positive. Moving down right here, we have angles formed by transversals. So what is a transversal? Right there in red, I have that a transversal is a line that intersects two or more lines. So if we look at the diagram, I have these two lines, and T would be considered the transversal because that line right here is intersecting both these two lines. And then angles are formed. You can see a total of 1, 2, 3, 4, 5, 6, 7, 8 different angles are formed when I have two lines in one transversal. What we're saying right here is this: two angles are corresponding angles when they have corresponding positions. Example, angles 2 and angle 6 are corresponding. Think about this. Both of these angles, they're at the top right. They correspond. I could also say right here, there's actually several corresponding angles. If I number these, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll show you right now which angles are also considered corresponding. If I look right here at the top left, we have angle 1. Angle 1, and down right below, we have angle 5, which is also in the top left of the intersection. Those two are considered corresponding. I'll have 3, angle 3, and angle 7, angle 4, and angle 8. And we have now listed all 4 pairs of corresponding angles. Okay, so there's quite a few. Next up, alternate interior angles. If you think interior, that's inside. So I think about inside of the 2 lines and the transversal, therefore angles 4 and 5 right here. Okay, those 2. Alternate interior angles. They're on alternating sides of the transversal. What I could also say here is this, that angle 3 and angle 6, those are considered alternate interior angles as well. They are on opposite sides of the transversal, alternating, and they're in between the 2 lines. All right, we have alternate exterior angles, exterior being outside of the 2 lines. And so let's go ahead, I could say this, we have angle 1 and 8, they are on alternating sides, once again, of the transversal, and they are on the exterior, on the outer side. We also have, if I label this angle right here 2, and down right here next to 8, that's angle 7, we could say that angles 2 and angle 7 are also alternate exterior angles. All right, and then finally, the last one are consecutive interior angles. They are on the same side and then on the interior or between the 2 lines. So we have angles 3 and 5. What I also have right here, we could say is angles 4 and 6. Okay. Those are also consecutive interior angles. All right, moving along. Let's go ahead and see if we can put all of this stuff together right here. So we have, take a look at number 1 through 4. We're going to look at this diagram and determine which lines are skew to line FG. Okay. Remember, skew lines are lines that do not intersect. Okay. Now here's the key to this question, and you're going to see this on your tests. And if we were to have a quiz, typically you'd see this on the quiz as well. Don't forget, it says which lines or planes contain point B and fit the description. So point B has to be used in your answer. Otherwise, there could be a lot of different answers. And there might be a lot of answers anyways. But specifically must contain point B. So remember, skew lines, 2 lines that do not intersect right here. I can go ahead, I look at point B, and I will say right here, and hopefully you start jotting some of these down as well. I could say that we have line BC, or even segment BC. Okay, that would be 1. We have as well, remember, any 2 points create a line. So I could also technically say that line BD is 1 as well. And if we get really technical, we could say BE is skewed to line FG, and then we could also say BH is also skewed. But I would say at least the main ones that you should get are BC and B to D. All right, next up, number 2. We're looking at lines perpendicular to FG. All right, I must, once again, it must contain point B. So if I look right here and I see that there's a symbol right there, it has to be line BG is perpendicular to FG. Number 3, lines parallel to FG. Okay, so FG right here, line parallel to that. Now here's the thing, you see we have a 90-degree angle there, and down right here at point B, we also have a 90-degree angle. One of our characteristics is that lines are parallel if they have the same slope. So if they're parallel, that means they both have 90-degree angles. That means their slope will be the same. that makes those two parallel. So we can go ahead and say line BA is parallel to FG. Is HE parallel as well? It is. But the problem stated it has to contain point B. So that wouldn't be a correct answer here. On number 4, lines parallel to plane FGH. So FGH, that will be this plane that's in the back. So a plane that's parallel to the one that's in the back would be this face in the front right here. And remember, 3 points make up a plane. You better make sure one of those points happen to have point B in it. And I can go ahead and say plane A, B, C. You can name it point CBA, BCD, DCB, you name it. As long as point B is one of those 3 points, then you've got yourself an answer. Let's go ahead and move on. We have a numbers 5 through 8. Use the diagram. So let's say it says name a pair of parallel lines for number 5. Remember, parallel lines have the same slope or they will have the same markings. Okay. One of the things I see right here, see the two arrows. I could say that line VU, that is parallel to line RQ. So there's one. Next up, we have W and Y down here, or near those points. I see one set of triangles right there. So what I could say is that line WX is parallel to line YZ. All right. So those two right there are parallel. We have 2 sets of parallel lines. Look for those arrows. Okay, and that is the symbol that will tell you which lines are parallel. Taking a look at number 6, name a parallel pair of perpendicular lines. Remember, lines that are perpendicular, they've got this right angle. They're 90 degrees. So name a pair. One of them would be, we could say line SN. And I'll use the perpendicular symbol right here. It's perpendicular to line UN. Now, this is a very important one. A little tidbit right here. You can see that SN and UN are perpendicular. But we also have another one. This line SN, which is also like we could say is ST if we expand it down. You can see how it's parallel. Remember, if these two are parallel right here, then what that will tell me is that these two lines, they're parallel to this transversal. And if they're both 90 parallel, that means, and they're both with this transversal, they're both going to have the same answer. So what I could also say is SN is perpendicular to line QR. And that works as well. Looking at number 7, it says, is WX, I'm looking right here, WX, is that parallel to QR? WX and QR, that would right here be a big no. Look at the symbols, they're not even the same. No. Why? They intersect. Remember, parallel lines shouldn't intersect at all. And those intersect, so that is no good. Next up, take a look at number 8. Is line ST right here perpendicular to line NV? I look at ST right here. I look at line NV, which is right here. And the question is, are they perpendicular? Now let's say that that is a big yes. Remember, if you look at it, lines intersect to form a right angle. That would be an explanation. Remember, you must make sure you can explain, explain, explain. All right, that is the key to success in proofs and in this chapter and in all chapters. And also right here, there's exactly one line through point V perpendicular to ST. Okay, that could also work as well. Let's go ahead and move along. Identify all pairs of the given types. And we kind of went through this earlier. It's a little bit complicated because looking at some of the way things are set up. But let's go through them. I'll go ahead and put angles 1 and 5. They're corresponding, right? Look, they're both on the same side of that transversal. If I'm looking at the transversal right here in blue, they're both on the same side. So hopefully we can also say 6 and 2, right? That's another set of corresponding angles. Angle 6 and 2. If I were to draw right here, let's draw a red line going this way. And I look at actually, let's stay with the blue. Let's look on the other side and what corresponds over there. Hopefully you got angle 8 and angle 4. I also have angle 7 and angle 3. All right, so those right there are corresponding angles. We have a lot. So if I were to draw this red line right here, I look on the right side of this red line, I can say that angle 6 and 12. I've got angle 8 and 11. There is angles 5 and 10. We have angle 7 and 9. Okay, those are all corresponding as well. And then there's also quite a few. There's four others. If I were to right here, use that green line as my transversal. And then I can go ahead and put right there. We have, let's say, 2 and 10, 4 and 12, 1 and 9, 3 and 11. Okay, those are all different corresponding angles there. They try to confuse you because we got 3 different lines that intersect each other, and you gotta always think, well, what's on the same side? What is that transversal? Maybe you need to highlight it so you can realize, all right, this is the line I'm looking at. Look on the left side, look on the right side, and so on. We have alternate interior angles. So let's take a look right here again. If I take a look, let me go ahead and draw this blue line again. Along this line right here, alternate interior. So it should be on the inside because these are the 2 lines that are right there, and we have the blue. So alternate interior, I could say, is 5 and 4. We have also 7 and 2. With the red, good old red, there is angle 7 and 12. We have 8 and 10. And then finally right here at the bottom with green, alternate interior angles would be 4 and 9. We have 3 and 10. Alternate exterior, those would be on the outside. So we take a look at the blue line. On the outside would be 6 and 3. That will be on the outside. We have also 8 and 1. In the red line, we have angle 6 and 9. There's 5 and 11. And then we have right here on the green line, we got angles 2 and 11, 1 and 12. All right. We also have right here consecutive interior angles. We're looking on the inside. If we take a look in blue, right there we have 7 and 4. Right, they are consecutive interior right here on the inside. If we look on the inside right there on the other side of the transversal, we also have 5 and 2. All right. We look over here on the red. We've got angles 8 and 12 would be interior. Consecutive interior, 7 and 10. And then in green right here, on the inside of the two lines that the transversal goes through, 4 and 10 is one of them. So I'll go ahead and put right here angles 4 and 10, and also angles 3 and 9. And there you have it. We have figured out all the different parts and angles of our corresponding lines, alternate interior, alternate exterior, everything we need to know about these lines. When we go to 3.2, we'll add one more thing to it. We'll talk about parallel lines and their transversal. All right. Well, I'm going to have to go. My dog wants food. Maybe you heard it barking. And I'll see you guys for 3.2.